Okay. These are the three types of equations you will need to solve. And what I mostly mean by that is here's what I want you to realize. Once you start to solve it, it doesn't matter whether it's sine, cosine, or tangent. Okay? All that means is at the end here, you're going to have a different button to push. You get what I'm saying? It doesn't matter. You know, you're going to solve tangent of 30 degrees equals x over 10 the same way you're going to solve sine of 30 degrees equals x over 10. The only thing's going to change is what button you push at the end. And you'll see what I mean here in a little bit. Now, first of all, though, get your calculators out and let's talk about these calculators and how you do this. There are two types. The one I have here is one that's probably like the stock, more like the stock iPhone calculator. Okay? And how I usually do this is I just do a simple addition problem to show you the difference. If I said 2 plus 4 equals, did you ever see the 2 and the 4 on there at the same time? Look up here. No. When I said 2 and then I pressed plus, it kind of blinked a little bit, didn't it? That means that's kind of telling you hit that. This is the old kind of calculator. 4, and then you press equals. This is not a scrolling calculator. This is different. This you put the number in and then you press your function. For instance, if I wanted to find the square root of 16, okay? What do? Well, I first put the number I want to find the square root of in, and then I press the function, which is what? Find the square root of that for me, calculator. And so it did. If I wanted to square 16, I put the number in and say, hey, square that for me. Okay? You guys see the point I'm making. It's the same thing if I wanted to find the sine of 16 degrees, a 16-degree angle. I put 16 in, and then I press the what? Sine button up there, and it tells me what it is. It's just a number. So when we do these with equations, we treat it just like a number. When there's a number, you know, we're finding the sine of a number or anything like that. Now, sine of a variable is a little different. Okay? So that's how you do those type. Now, here's the difference I'll show you. What most of you probably have is a scrolling calculator. And what I mean by that is when I press 4 plus 2, what do you see up there? The 4, the plus, and the 2. When you have a calculator like this, you press equals, then it'll just show you your answer. But some of them will do what I'm doing right here and kind of showing you the answer as it goes along, isn't it? Then if I said minus 2, it goes back to what? 4. These, you put stuff in these as you would write it on a piece of paper. See, if I went 16 and then press sine, what is it doing? It's saying 16 times sine for something. It did that for me. I'm not finding the sine of 16. But how would you normally, when you write sine of 16, you usually write what first? The sin, right? So when you find the sine of 16 here, you press sine first, and then you put what number you want to find the sine of, then you close your parentheses. See, we get the same number. Same thing here as far as square root. Square root of 16. See how I put the square root sign in first? So that's the difference between these two. One, you do the function first, one, you do the function second. You need to know what type you have and be able to use both. Moral, though, sine of 32 degrees is just a what? Number. Okay, sine, cosine, tangent, they're functions. That's why they're called a sine function, just like square root is. And don't make it harder than what it is. There's a whole class dedicated to this for helping you understand what sine, cosine, and tangent are. You don't need to understand what they are. You just know it's a function that your calculator does the hard work for you. That sine is what? Opposite. The sine of an angle is always the opposite leg over the what? Hypotenuse. Don't make it harder than what it is. okay? We just need to be able to use it to find, you know, the sine of what angle sine is 5 over 10. You know, we need to be able to do that. So back to this. How are we going to solve these? Well, first I've got to set them up. And as I said before, I don't get it why when I say do it exactly how I do it. That's not a confusing thing, is it? When I do it on the board for you, I say do it exactly like that. That shouldn't be confusing, should it? I wouldn't think so. But conveniently, it seems to be, because you guys want to put your own spin on things. For example, I said I always wanted you to what? For now, because I'm trying to teach you, I want you to circle your angle. Then with respect to that angle, I want you to tell me what each side is. It's either what? Opposite, adjacent, or the hypotenuse. What is this x? It's the opposite leg. What is this 10? Hypotenuse. Hypotenuse stays the same. It's all opposite that. So you've done what I asked you to there. And then I asked you guys to set it up. Well, it's always, so opposite hypotenuse. Which trig function fits that? Sine. So it's always sine of an angle. What is our angle? So sine of 32 is equal to, well, it says to put the opposite. What's the opposite? Over the hypotenuse, which is, so we set that one up. Over here, how would I set this one up? Circle my angle, because everything works off it. With respect to this angle, what's the 10? Opposite, what's the x? And I remember I asked you guys to put the O, the P, and the P, and the HYP, because I didn't want you getting lazy. I wanted you to kind of say the name to yourself. When I say to do that, you ought to do that. Amazes me why you guys won't listen. It kills me. I asked you to write down 3 letters. So, with respect to this, I'm giving opposite and hypotenuse. Which one is that up there? So the sine of what? An angle, what angle? Is equal to the opposite, which is 10 over x. Everybody got that? Not supposed to have it out there in notes. Doggone it. You know that. Now, look here. How would I set this one up? Circle my angle. With respect to this angle, what's given to me? Opposite, and what's this? Adjacent, because it's not the hypotenuse, is it? So what is that one? Tangent of what? Is equal to 12 over what? Very good. Now, how are we going to solve these? Well, let me try something at you. This one right here. Let's talk with just this one right here. Okay, I remember I said that's just a number, right? Well, if I had 4 is equal to x over 10, could I not change that to 4 over 1 and then do what? Because I've made it a proportion, I can cross multiply, right? So 1 times x would be what? And then this would be 4 times what? X would be what? How easy of an equation is that to solve? Would you guys agree that's really, really easy? See, here's what you're going to understand about some of this sine stuff. The equations we're actually going to ask you to solve are extremely simple, very basic, pre-algebra stuff. It's just we're adding a little bit of a weird thing in there, which is what? Yeah, something you're not used to dealing with. You'll find that a lot of times in math, it's things sometimes easy computations, new and sometimes complicated concepts. This one's really not that complicated because I know that represents a number, don't I? So can I not put that over 1? Now, do I have a proportion? what could I do? So 1 times x is what? And this would be sine, I'm going to go ahead and not write the parentheses and put it like that. Sine of 32 times what? 10. Now, if you look at these two right here, are they really that different? These two equations I'm trying to solve? They're really not, are they? It's just I had this big ugly number, and then I had this big nice pretty number. Well, guess what? When I put it into my calculator, except, and here's the deal. I will say in some ways this is almost harder. Why? Because you had to know what 4 times 10 was, right? I kind of really don't. I guess you could use the calculator for that too, but here, calculator's going to do all the work for me. I'm going to say what? Sine of what? 32 times 10. And then I press equal. What do I get? X is equal to 5.299192642. Now, you don't have to write this long, huge thing out. I don't have to see this step, but I got to see this one. You don't have to draw the arrows either. This one, and then the one I'm about to. They say to round to the nearest tenth. So what would that round to? 5 point what? 3? You're done. Isn't that ridiculously simple? I mean, you put it over 1 and you cross multiply. Whether I change that to tangent or cosine, change that to 150 and change that to y, it doesn't change, does it? You're still going to do the same process. So this is a template on how to do one when the x is what? Right there. Because that's really what's different about all these three, isn't it? Where the unknown is located. Okay, so that's how you're going to do one where the x is at the top right there. Because aren't we going to always have 3 things here? So now let's move over to this one. See how it's very close to the same thing. What's the difference now? I even kept the numbers the same, except I changed which one was my unknown, didn't I? Since the x is over here, and this is just a number, do you think my process changes at all? What do I probably need to do? Put this over 1. Now it's a what? Proportion. What can I do now? Cross multiply. Well, I'm going to write this as sine of 32 times x is equal to, what's 1 times 10? Now, what's a little different now? It's on the opposite side now. You know, the x was by itself, wasn't it? It was already solved for. Well, my question to you, and I heard somebody say it, so I think you're starting to get it, and I'll use a 2 this time. Would you guys have a problem at all solving that equation? What would you do? Divide both sides by 2 because you want to make that into a 1, right? You want to know what 1x is equal to, and make something into 1, you divide by itself, don't you?
Yes.
So x would equal what? Well, in general, didn't you just have a number right here? And you divided both sides by whatever that number was? Would you guys agree with that concept, that that's kind of in general the concept of what you did right there? What did I just say sine of 32 is? It's just a number. Any number you divide by itself, what do you get as the answer? 1, right? So if I divide this by itself, I'm going to get just an x here, aren't I? Would you guys agree? But what allows me to do that? If I divide the left side by sine of 32, I have to divide the by sine of 32. And that, like I said, that's just a number. Now, you could put 0.529919262 x right here if you wanted to do that first, right? But isn't that a little easier, right? And just get over there? I would save doing the sine and the calculator part till the end. And that's what I meant by, if this was a tangent, the only thing that changes at the end, you press what? Tangent instead of what? Sine. You let the calculator do that work for you. So here, what am I going to do? I'm going to, what is it? 10 divided by sine of 32. What does that equal? 18.87. Rounded to the nearest tenth, what do you get? 18.9. This is what I expect to see here on your paper here. Like I said, I don't have to see this step here. So is there any confusion when I say this is exactly what I want it to look like? Shouldn't be any problem, should there? Now, moving on to the third one. What seems kind of drastically different here? Our unknown was the side of the triangle, right? Now we've completely changed what type of number. It's the what? So our answer will actually be in degrees, won't it? This makes this different. Okay? Right here we were multiplying to x, right? So you know what we did? We did the inverse function of multiplication, which is division. That will always give you 1. So I wanted to know, hey, sine of 32 times what is 10? Well, then you do the inverse. You divide by that number instead of multiplying by it. You do the opposite. Here's no different, except that the inverse function on a calculator, it's kind of done for you. And what I mean by that is everyone look at this calculator. What is above the sine, cosine, and tangent? No, right above it. The button there. What do you guys see? Right, the letters right above sine, cosine, and tangent. Okay, I'll get it closer. No, it's not a 1. Cosine -1, tangent -1. That -1 means inverse. Okay? So if you press the second function button and then sine, you're going to do the inverse sine, the inverse cosine, or the inverse tangent. What that is, and don't tune me out because it sounds weird. All it is answering this question. What angle's tangent is 12 over 10? What angle's tangent is 12 over 10? But here's what I want you guys to write on your paper. Every time you get, and what do you have to remember when your unknown is the? That's when you're going to use what? Inverse functions, right? But your first step is I want you to write this inverse function. So you're going to say tangent, but you're going to change this to -1. Well, what are you going to find the inverse tangent of? Whatever's on the other side. 12 over is equal to, I want to see that step right there. So those of you that had done this a little bit and used inverse tangent, this is the only thing you left off. I want to see you write this statement here. I want you to understand that you're finding the inverse tangent of what? What's on the other side, 12 over 10. You're telling me that you at least use this button on your calculator by writing that. Does that make sense? So if you had the cosine of x is equal to 8 over 10, how would you solve this one? X would equal what? The inverse cosine of what? Does that make sense? All you've got, now the rest of this is what? Calculator work. And I think in art, they actually ask you to round to the nearest degree. So, how I do it here is I first need to do 12 divided by 10, don't I? So I go 12 divided by 10, and I'd press equals. 1.2 is the answer. Now, I want inverse what? Tangent. So what am I going to press? The second function, because that's yellow, right? Inverse tangent. What does it say it is? It's a 50.192. It's 50.192 or 194428891 degrees. And they want us to round that to the nearest what? Degree. So that would be what? 50 degrees is your answer approximately. Not that bad, is it? I know that's weird writing that down, but that's even fewer steps than these are. Important, guys. Here's what I found that a lot of people will do. They'll solve all the ones that are like this, where you don't have to do anything but cross multiply, right? And then I'll look on their paper. Anytime they got to this point, they stopped because they got confused and didn't try to just investigate a little more. Or when they get to one of these, they stopped. I don't get those, Coach. Okay, I understand that. I don't expect you to know how to do it from hearing me say it once. Why do you think I did one of each example? So when you're doing your work, you can say, okay, which one of those is it? Okay, how did he do it when the X was right there? You follow these steps. You see, you look at the process of which I did. Hey, what did he do when the X was right there? Oh, when he got an X beside the sign here, he did what? Divided both sides by sine of 32, right? Hey, what in the world did he do when he had that? He brought whatever was over here, put it inside the parentheses, changed that to a -1, and put the X on the other side. So see, there are templates for you to do that, isn't there? Then hopefully you'll start understanding as you do that over and over, okay? Your assignment is, of course, and it's due at the end of the hour on Wednesday. There will be no exceptions. It is not due first of the hour Thursday. I will not make that okay. You should come to my class Wednesday ready to grade and ask questions. You should have most of these done. You have 4 days. You are in high school. You are allowed to have homework on weekends. Okay? You're not in kindergarten anymore. Now, this shouldn't take you very long. So, get this done. You should, if you did what you were supposed to do and you set all of them up correctly, you have labeled. Everybody hear me? What did I say? If you don't label these, am I going to count it wrong? Yes. Trying to teach you how to think about these. If you've already set it up, all you've got left to do is that, isn't it? And that's really not that bad. I'll have, of course, the key here for you to grade and correct on Wednesday. Any questions? You have to, of course, then solve. You need to get all of that worksheet done now, including the solving. Let's get to work. You have 6 minutes. I expect you to use